What if the ice that crowns the world vanished in an instant? No more Antarctica. No more 58 meters of water added to the oceans. Our coastlines would disappear. Cities we know, drowned. The climate we trust, broken. Let's see what truly happens when the frozen south melts completely. Antarctica holds 90% of Earth's ice. 30 million square kilometers of solid water sit at the southern pole. If it vanished, global sea level would rise about 58 meters. That is more than 180 feet of water covering the planet. Ice loss is accelerating. Scientists warn of tipping points that could turn a gradual melt into a rapid collapse. In this video, we will follow the water, the climate, the life, and the world that would be left behind. Imagine the ocean swelling by 58 meters in a single moment. Low-lying continents would be swallowed. The flat lands of Bangladesh, the reclaimed polders of the Netherlands, the sun-kissed beaches of Florida would vanish beneath a relentless tide. Megacities would become islands of ruin. New York's skyline would dip below the horizon, its streets turning into canals of darkness. The economic loss would run into trillions of dollars, a scar on the global ledger that no nation could afford. A heat map of displacement would show half of today's human population forced inland, seeking higher ground that no longer exists. But the water is only the beginning. The white surface of Antarctica reflects a huge portion of sunlight back into space. Without that bright mirror, Earth would absorb far more heat. The planet's albedo would drop dramatically, pushing global temperatures higher than any record we have seen. The Great Ocean Conveyor, the Atlantic meridional overturning circulation, would stall as fresh meltwater floods the Southern Ocean. A shutdown of this circulation would rewrite weather patterns across the globe. Superstorms would rage with new ferocity. Droughts would carve deeper scars, and wildfires would blaze across continents that once knew moderate rains. In a matter of decades, the planet could settle into a harsher climate regime, a new normal that reshapes every ecosystem. Now consider the life that thrives beneath the ice. Antarctic krill form the base of the Southern Ocean food web. Billions of krill swarm beneath the ice, turning microscopic algae into a protein-rich feast for larger creatures. When the ice disappears, krill populations collapse, and with them, the food source for penguins, seals, and the great whales that migrate south each summer. Empty breeding grounds would echo with silence. Global fisheries would feel the shock as the loss of krill reverberates up the chain, causing fish catches to tumble worldwide. A single continent's loss could starve half of the ocean's predators, a cascade that ripples through marine ecosystems far beyond the polar seas. If this is blowing your mind, hit subscribe to DNA Explained and stay with us as we uncover the next layer of this unfolding disaster. The loss of the polar cap would also rewrite the chemistry of the world's oceans. The icy shelves act as a giant freezer, trapping carbon dioxide in the form of dissolved gases and in the sediments below. When the freezer disappears, that trapped carbon would be released, turning the seas into a silent furnace. The concentration of carbon dioxide in seawater would climb, making the water more acidic. Marine organisms that build shells from calcium carbonate would struggle to grow. Coral reefs, already on the brink, would face a sudden surge of acidity that could dissolve their structures within a generation. The loss of reefs would erase habitats for countless fish species, further destabilizing food webs that support human fisheries. Beyond the marine realm, the the shock. The massive weight of the ice sheet presses down on the continent's crust, keeping it depressed. Without that load, the land would begin to rebound, a process known as isostatic uplift. This uplift would not be gentle. Fault lines buried beneath kilometers of ice would be released, triggering earthquakes in regions that have been quiet for millennia. The sudden redistribution of mass would also affect the planet's rotation, nudging the poles ever so slightly. A shift in the axis would alter the distribution of sunlight, reshaping climate zones in ways that are difficult to predict. The meltwater itself would carry a payload of ancient pollutants. Deep within the ice lie particles of soot, microplastics, and even radioactive isotopes from past atmospheric testing. As the ice melts, these particles would be flushed into the Southern Ocean, spreading contamination across marine ecosystems. Fish that ingest microplastics would pass them up the food chain, eventually reaching the plates of people far from the poles. The health implications would be global, linking the fate of the Antarctic to the well-being of distant communities. A cascade of feedback loops would amplify every effect. Warmer oceans would melt the remaining ice faster, releasing even more fresh water. The influx of fresh water would dilute the salinity of the Southern Ocean, further weakening the conveyor that transports heat around the globe. That weakening would allow heat to build up in the upper ocean layers, leading to more intense storms. Each storm would stir up coastal sediments, releasing trapped methane from the seabed. Methane, a greenhouse gas far more potent than carbon dioxide, would accelerate warming in a vicious circle. The planet could find itself trapped in a self-reinforcing spiral, where each new change fuels the next. Human societies would be forced to adapt in ways that stretch imagination. Coastal megacities, already fighting rising tides, would have to confront waters that rise by more than 50 meters. Entire island nations would vanish beneath the waves, erasing cultures that have existed for centuries. The displacement of billions would create a wave of migration that no current political system is equipped to handle. Borders would be redrawn, economies reshaped, and resource conflicts could flare as nations compete for dwindling arable land and fresh water. Freshwater supplies would also be at risk. The Antarctic ice sheet stores a vast majority of the planet's freshwater. Its disappearance would alter the balance of the global water cycle. Regions that rely on meltwater from the southern polar region, such as parts of South America, would see a dramatic drop in river flow. Agriculture in those areas would suffer, leading to reduced yields and heightened food insecurity. The stress on water resources would ripple outward, pressuring ecosystems from the Amazon basin to the African savannas. The loss would also expose new geological treasures, but at a terrible cost. Minerals locked beneath the ice, such as rare earth elements and precious metals, would become accessible. The temptation to mine these resources could spark a new rush, drawing corporations into a fragile environment that is already on the brink. Extraction would further disturb the delicate balance of the region, releasing more dust and pollutants into the atmosphere. Yet, the story does not end in inevitable doom. The same scientific community that uncovered these threats is also charting pathways to mitigate them. Cutting greenhouse gas emissions remains the most direct lever to slow the melt. International agreements that bind nations to carbon limits could keep the temperature rise within a range that preserves a portion of the ice. Geoengineering proposals, such as injection miles into the stratosphere, aim to restore some of the lost albedo, though they carry their own uncertainties. Conservation of existing ice through artificial cooling projects is being explored, albeit at a scale that currently seems daunting. Adaptation strategies are also emerging. Coastal engineering that combines natural wetlands with elevated infrastructure can provide buffers against higher seas. Relocation plans for vulnerable populations, though fraught with cultural and logistical challenges, are being drafted in advance to avoid chaotic flight when the waters finally arrive. Investment in resilient agricultural practices, such as drought-tolerant crops and efficient irrigation, can cushion the impact of altered freshwater flows. The key lies in recognizing that the Antarctic is not an isolated slab of ice, but a central hub in a global network of climate, ocean, and life. Its fate reverberates through every continent, every ocean, every living being. The images of drowned skylines and silent penguin colonies are more than tragic vignettes. They are warning signs that the systems we depend on are intertwined. Ignoring them would be to gamble with the very foundations of civilization. So, as the ice melts in the remote south, the world feels the tremor in its heart. The water rises, the temperature climbs, the chemistry shifts, the land uplifts, and the human story is rewritten. Each layer of this unfolding disaster reveals a deeper connection, a tighter feedback, a more urgent call to action. The choice before us is stark: to heed the evidence and act, or to watch the continent fade and accept the cascade that follows. If this is blowing your mind, hit subscribe to DNA Explained and stay with us as we uncover the next layer of this unfolding disaster.